So let's have a look at this. So the first step is, yes, we're going to use polynomial division. On this, which means we're going to divide x plus 3, x minus 4 into this expression here. So that's what we're going to do. If you think back to the last example, we ended up with remainders that we were subtracted from the x squared and the x's and so on. So we need this to be in the same form as that. So we need to multiply out these brackets. So x times x gives us x squared. And then we've got minus 4x plus 3x is minus x. And 3 times minus 4 is minus 12. So we've got x squared minus 4x plus 3x is minus x. And then 3 times minus 4 is minus 12 into this. So how many lots of x squared are there? What have I got to do to x squared to get 3x squared? Or how many lots of x squared are there in 3x squared? 3. And then I multiply 3 by this expression, this whole expression. So 3 times x squared, 3 times minus x, 3 times minus 12. And that then goes underneath. So 3 times x squared gives 3x squared. 3 times minus x is minus 3x. And 3 times minus 12 is minus 36. Work out the remainder. 3x squared minus, we're taking away, it might be worth thinking about that, we're subtracting this whole expression from the top. So minus 3x squared minus 3x squared is nothing. Remember, that has to become 0. If it's not 0, you've gone wrong. Minus 4x minus 3x is plus 3x, so minus 4x plus 3x is minus x. And the last one, 2 minus again is plus 2 plus 36 is 38. So you have to be really careful with the signs when you're working out remainders, because you're subtracting, you could easily end up with a double negative. Stop there, because the power of what my remainder is lower than the power in the device, or which way around it is. Okay? So we've got an answer. We can say that our original fraction, 3x squared minus 4x plus 2 over x plus 3 x minus 4, putting it back into that into its factorised form, equals 3. And then the remainder plus, if I write the positive bit first and then minus x over my expression, which again I'm going to write as x plus 3 x minus 4. So our original integral can now be written as the integral of this. And so all I've got to do now is my method of partial fractions again on this bit here. Split it up, put it a over x plus 3 plus b over x minus 4, and work out what a and b are. So, try to just do that. If we split this then into a plus b, and this is common, instead of having to rewrite the denominator all the time, just put d for denominator. You could define d as this if you want, as a little aside. So if you're writing it a lot, that's reasonable. So you split it, then you recombine it, so it's all this lot over the denominator. So now we can equate denominators. We get this same familiar pattern. If I let x equal minus 3, this term will disappear, so I can find a, and vice versa. If I let x equal 4, this term disappears, so I can find b. And these turn out to be the values. So that means that the original integral can be rewritten as this, and so then we can just do it using the standard integral. So once you're familiar with it, and you've done it a few times, it just becomes routine. The first thing to ask yourself is, do I need to use polynomial division? And the answer is yes, if the power of x in the denominator, in the numerator, is greater than or equal to the power of x in the denominator. So I have to use polynomial division to get the whole number part, and then fractions, partial fractions to do the rest, and then I've done this. Okay.